In this example, we're going to solve this equation by factoring. So the first thing we need to make sure of is that all the terms are on one side of the equation and they're equal to 0, which they are because that's the way the problem is given to us. Okay, so if we're going to solve this by factoring, now we need to look at this left side that has all these terms, and we need to figure out how we're going to factor this. Well, the first thing for factoring is we always look for a greatest common factor that can come out to begin with. And it looks like all these terms have a's. So let's go ahead and factor an a out. So I'll be left with a squared minus 4a minus 21, and that'll equal 0. Okay, so here, these leftovers, I need to find a way to factor these, and it looks like I have a quadratic trinomial. The leading coefficient is 1, so I can set this up like this and put a's at the beginning here, because a times a makes my a squared. But now I need to figure out what two numbers multiply to make negative 21 that add to make negative 4. And those values I can go ahead and fill in these parentheses. Okay, well if they multiply to make negative 21, let's think about the factors of negative 21. We have 1 and 21 and 3 and 7. And if they add to make a negative, we know the larger of these has to be negative, and they multiply to make a negative, so we have one of each, one positive, one negative. So it's either going to be positive 1 and negative 21, or positive 3 and negative 7. And it looks like the positive 3 and negative 7 is the obvious choice because those are the numbers that add to make negative 4. So let's go ahead and put those in, plus 3 and minus 7. So we have this left side factored completely now. So what this looks like is I have a, and then a plus 3, and then a minus 7, and all of these factors are being multiplied together, and they give me 0. So I can use the 0 property of multiplication, which says if I'm multiplying all these and I get 0, well, one of these has to be 0. So I'm going to account for all of them, and I'm going to go ahead and set each factor equal to 0. Well, the first one looks like a equals 0. That's already solved. The second one, I can subtract 3 from both sides, and I'll have a equals negative 3, and that's a second one. And here I can add 7 to both sides, and I'll have a equals positive 7, and that's the third value. So it looks like this equation has 3 solutions, and they're going to be 0, negative 3, and 7. And I would challenge you to go ahead and plug all 3 of these values back in and just ensure that they work. And in fact, they will. So we have now solved this equation by factoring.